Hi designers, welcome to SolidWorks Central. In this tutorial, we'll be designing a realistic crane hook, step by step. We'll begin by creating the base profile, then draw the guiding paths and additional profiles for a smoother shape, and finally complete the remaining parts of the hook. Today's key commands include plane, lofted boss base, dome, cosmetic thread, extruded boss base, and chamfer. We'll also finish the scene by applying materials and appearances to give our model a professional look. If you'd like to review or download the technical drawing, the PDF file is available for channel members. Let's dive in. Start by creating our first profile. Open a sketch on the top plane and select the circle tool. Draw a circle with its center positioned at the origin. Activate the Smart Dimension tool and set the circle's diameter to 52 mm. That completes our first profile. Exit the sketch. Continue by drawing the path. Open a sketch on the front plane. Select the Centerline tool. Start from the origin and draw a vertical centerline downward. Then draw a horizontal centerline to the right. Double-click to temporarily break the relation and continue drawing freely. This helps when you want to start a new line elsewhere without leaving the tool. From there, draw another vertical centerline downward. Select the Smart Dimension tool. Set this centerline's length to 220 mm. Now, start drawing the first path. Select the Line tool. When you return to the point, an arc will automatically appear. Continue with a straight line, then return to the point again to switch back to an arc. Leave the arc at this point and draw one more arc. Delete the tangent relation between these two arcs. Select the Smart Dimension tool. Set the radius of this arc to 45 mm. The distance between the arc's center and this point is 138 mm. Set the radius of this arc to 94 mm. And set the radius of this arc to 82 mm. Rotate the sketch view slightly. Apply a make-pierce relation between the starting point of this line and the circle profile we created earlier. Make-pierce creates a relation that forces a sketch point to lie exactly on another sketch or 3D curve, often used to connect paths and profiles in loft or sweep features. Align the arc's center horizontally with this point. Select the Smart Dimension tool. Set this distance to 11 mm. And the distance between this point and the end of the arc is 71 mm. Now the sketch is fully defined. This becomes our first path. Select the Circle tool. Draw a circle from this point. Using the Smart Dimension tool, set its diameter to 70 mm. Now, select the Line tool and start drawing the second path. Add a tangent relation between this line and the circle. Also, add a tangent relation between the arc and the intersection point of the line. Select the Smart Dimension tool. Set the radius of this arc to 125 mm. The vertical distance between the centres of these two arcs is 7 mm. Also, apply the make-pierce relation here as well. Now this path is fully defined. Activate the Trim Entities tool. Keep Power Trim selected. Trim the extra parts of the circle. Now, let's create the tip of the hook before moving on to the profiles. Select the 3-point arc tool. Draw an arc starting from this point. Draw another arc starting from this point. And draw one more arc to close the end of the shape. Activate the Smart Dimension tool. Set the radius of this arc to 125 mm. And set the distance between the arc's centre and the centre line to 34.5 mm. Set the radius of this arc to 125 mm as well. Make sure the arcs and their centres are not connected to any other geometry. If you see an unwanted relation or get stuck, simply delete the arc and redraw it. Hold Shift, select the upper part of this arc and the centre line, and set the distance between them to 50 mm. Holding Shift allows you to pick from external references when adding dimensions. Set the radius to 10 mm. Select the free centre point of this arc and make it coincident with the centre line. Then add a tangent relation between the intersection point of these two arcs. Select the centerline tool. Draw a centerline between these 2 points. From the midpoint of this centerline, draw another centerline perpendicular to it. This will be useful for the dome feature. Convert this arc into construction geometry. Now activate the Sketch Fillet tool. Set the fillet radius value to 100 mm. Apply it to the 2 intersection points. Right-click to confirm. These fillets will give us smoother and cleaner transitions. The sketch is now fully defined. You can exit the sketch. Now, let's start drawing the remaining 3 profiles step by step. From the Features tab, go to Reference Geometry and activate the Plane command. In the first reference box, select the top plane from the feature tree. In the second reference box, select this point. Now we've created a new plane that is parallel to the top plane passing through this point. Right-click to confirm. Open a sketch on this plane, look normal to it, and start creating the profile. Select the Centerline tool. Convert this line into a regular line. Select all entities and activate the Mirror Entities tool. In the Mirror About box, select the centerline as the mirror reference. Right-click to confirm. Select the 3-point arc tool. Close the open ends with arcs. Select the Smart Dimension tool. Hold Shift and add the outside to outside dimension between the arcs. Set the length to 70 mm. Activate the Sketch Fillet tool. Set the fillet radius value to 10 mm. Select all corners at once and apply the fillet. Reactivate the Smart Dimension tool. set the outside to outside distance between these two fillets to 25 millimeters. And set this one to 65 millimeters. Set the radius of this arc to 140 millimeters. And finally, set the radius of this arc to 70 millimeters. While holding Ctrl or Shift, select the midpoint of this arc. Now select the path, then add a make-pierce relation. The profile is now positioned correctly. This profile is complete. Exit the sketch. We can now hide the plane. Move on and start drawing the third profile. Open a sketch on the right plane. Select the Centerline tool. Convert this construction line into a regular line. Perform the mirror operation the same way as before. Close the open ends using the 3-point arc tool. Now, add the overall length between the outer arcs again. The exact value doesn't matter, we're just adding it as a reference for now. Set the length to 70 millimeters. Using the Sketch Filler tool, apply a 10 mm fillet to the corners. Select the Smart Dimension tool. The outside to outside distance between these fillets is 34.5 millimeters. And this distance here is 55 millimeters. Set the radius of both arcs to 58 millimeters. Hold down Ctrl or Shift, and first select the midpoint of the lower arc. Then select this point and add a coincident relation. As you can see, this part is slightly longer than needed. Delete the 70 mm dimension. Hold down Ctrl or Shift again, select the midpoint of the upper arc, then select the path and add a make-pierce relation. This way, we've positioned our profile neatly between the two paths. You can now exit this sketch. Only one last profile remains. Activate the plane command. For the first reference, select this point. For the second reference, select this point as well. For the third reference, choose the front plane from the feature tree. This will create a new plane that passes through both points and is perpendicular to the front plane. Click OK. Open a sketch on this new plane. Select the Circle tool. Start from the midpoint of the construction line and draw the circle up to this point. It should automatically be fully defined. Exit the sketch. That completes this final profile. Now it's time to use our profiles and paths. Activate the Lofted Boss Base command. In the Profiles box, select each of the profiles one by one. First profile, second profile, third profile, and fourth profile. Now, to get a smoother shape, select the Guide Curves. In the Guide Curves box, choose the paths. This will be our first path. Make sure the Select Open Loop option is checked. It allows you to select open curves all at once. Confirm the selection. Now select the second path as well. Confirm it the same way. Finally, click OK to confirm the Lofted Boss base feature. Perfect. We've completed most of the hook and it looks clean and smooth. Now, let's create a dome at the tip using the Dome command. Before that, go to the feature tree, find the Loft 1 feature and make Sketch 7 visible. We'll need it for the Dome command. You can easily find the Dome command using the Search Commands box. In the Faces to Dome box, select this face. In the Constraint Point or Sketch box, select this point. Click OK to confirm. Now we can hide the sketch we made visible earlier. That completes the hook section. Next, we'll move on to the upper part. Open a sketch on this circular face. Select the Circle tool. Draw a circle centered at the middle point. Activate the Smart Dimension tool. Set the circle's diameter to 42 mm. Now, activate the Extruded Boss Base command. Keep the end condition set to blind. Set the depth to 70 mm. Make sure the Merge Result checkbox is enabled. Click OK. Now, select the circular edge on top. From the Quick Access toolbar that appears, select the chamfer command. Make sure the chamfer type is set to angle distance. Set the distance to 4 mm. Click OK to apply the chamfer. Now, let's add a cosmetic thread. If you already know the command name, you can easily find it through the Search Commands box. In the Circular Edges box, select this edge. For the standard, choose ANSI metric. For the type, choose Machine Threads. And for the size, select M42 by 3.0. Change the end condition to blind. Set the thread depth to 60 mm. In the Start from a Face box, select this surface. This defines where the thread will start from. Click OK to confirm. To display the cosmetic thread, go to Options. Under Document Properties, switch to the Detailing tab. Enable the checkbox for Shaded Cosmetic Threads. Click OK. If you don't want to display the thread circle, go back to the same menu. And simply uncheck the Cosmetic Threads box. We've completed our model. Now let's adjust the scene and apply appearances. If you're practicing SolidWorks, keep going. Every design you finish improves your control and understanding of the software. Click Rebuild to update the scene. Now, let's move on to the appearance setup. Crane hooks are usually made from alloy steels such as AISI 4340 or AISI 4140, materials known for their strength, toughness, and reliability under heavy loads. They are heat-treated to increase fatigue resistance and long-term durability. For a polished and elegant look, I'll apply a brass appearance. You can also access the PDF of this drawing in the Join section. I'll soon be sharing a complete collection of PDFs, including different project examples, turning it into a growing reference library for SolidWorks practice. And that's how we've completed our realistic crane hook model in SolidWorks. If you found this tutorial helpful, don't forget to like the video, subscribe, and turn on notifications for more step-by-step SolidWorks lessons. Thanks for watching, and see you in the next design.